All right. Hello again. I just was asked how long I've been at Google. I had to think for a bit. It's been 7 years. But most of that I've not been on the cloud platform. I worked in technical infrastructure at Google. I worked a little bit on infrastructure in Africa at Google. And since 2 years I'm on the Google Cloud Platform, based in Berlin. I'm mostly working with customers and partners who implement stuff in the Cloud Platform. Yeah. And today I'm talking about containers, Kubernetes. Quick show of hands, who has heard of Kubernetes? Ooh, that's surprising. Okay, good. Then we're right. And because I didn't bring a general intro to Cloud Platform, I expect you to know what it is. If not, it doesn't really matter either. I will talk a bit about what clusters are, what containers are, how we use containers at Google, and then how you can get containers from Google. A little bit different, because it's not exactly the same thing. And if there's time at the end, I'll do a quick demo of Kubernetes and Google Container Engine. Yeah, I hope there will be. To start, just to give a bit of an idea where this whole thing coming from. Well, if you looked at computers in the 50s and the 60s, that's like the main thing that was like airline reservation offices had, and they planned all the reservations for the seats. And it was quite complex, and then on came the PC and was meant to make all of this much, much easier, because now every reservation agent could have something on this, like this on their own desk. But what did people do, and funnily enough still do, if you ever looked over the shoulder of someone doing your reservation or changing some tickets, you see they still work exactly the same way as people work using mainframes. They basically just emulated, they used their PC, which has a CPU on their own, just as a dumb terminal to talk to some central system, and yeah, and it's still going on like that. It was kind of the same way when the first smarter phones which could access the web came along. They just copied what we've been doing on the desktop and didn't really work that well. But we quickly found a way to do things a little bit different with apps and mobile web pages, etc., to actually take care of the form factor, and yeah, don't need to say much more about that. But it's the same thing. We tend to think if we have a new device or if we have a new way of doing some things, we try to emulate something we've been doing before. And it's a little bit what people have been doing with public cloud. And yeah, we don't like that idea, because we've built a cloud in Google for a long time and we haven't been using it really like people are using what they get now as the cloud, or actually what especially traditional companies want to use it for. And basically it comes from the premise that the data center is a computer. It's not a collection of computers, and that's how you should treat it. And we very, very, very early on start thinking about that way, that a software developer doesn't think about the underlying hardware and underlying infrastructure, but just has a system which scales and which operates and which self-heals, etc. And that's what we always call the cluster. When I started in Google in 2007, I never heard of this before. I was like, what cluster? What's a cluster? Oh, it's a bunch of machines over there. We can fail them all over. We can use another cluster for the whole thing. And so finally, people are talking about clusters in computing, because they need a lot of infrastructure for themselves. Lots of people writing now applications for millions of users. We're not the only ones. And you kind of have to get to that idea. Who here is using container technology in one way or another? Okay, that's about a third. And I guess, yeah, it's more and more people are looking at it since Docker became very, very popular. But containers are basically making it easier to deploy and run applications. And well, what is a container? It's a standardized way, a simplified way to package up an application and to talk to each other. And you don't talk within the container. Basically, between containers, you only talk using standard methods, using network and not using like procedure calls, etc. And then there's Docker, which I think it became GA mid-year, like May or June or something. And since then, or even before that, it had a huge following because it suddenly makes it easier to creating these containers, to packaging up, to have a directory of them, to deploy them, and to manage them, and all of that, which has been a bit missing from the system. Now, how does a container work? Well, if you look at cloud computing, any other virtualization technologies, if you think about VMs, it's basically you have like this way, you have a hypervisor, you have a kernel, you have libraries, you have your code. And there's a few things which are not so great. One thing is if you want to switch between different clouds, if you want to switch between different virtualization technologies, well, what you can do is you can take all of this, which is basically your virtual hard drive, and you can shift it to another machine. But if they use a different hypervisor, you need different kernel modules, so it won't work out of the box. You need to make sure you have all of them installed, etc., to make sure you can bring a VM from one system to another. So it's not really fully portable. And on the other way side, it also has another way. Once you want more than one app, because really a VM can be 4-core, 8-core, 16-core, you have libraries, and once you have several apps, I think we all seen that suddenly, well, app 1 needs version 1 of the library, app 2 needs version 2, they're not fully backwards compatible, and basically you can't really deploy them on one machine together without making it very, very complicated. So that's also not very great trying to do different things on one VM together, although you might have to do it, especially if you add always your monitoring agent, etc., that always needs libraries. So also, if you don't do that, well, if you run a VM for every app you have, or for every system you have, for every module you have, basically you have an overhead here. You have the kernel, which is always really the same operating system, etc., and that's very, very redundant. So that's another downside for it. So containers have the idea of, well, abstracting in a different way, of like putting the app code, the library together, but separating it from the kernel and the base operating system and the hypervisor, if you use VMs, etc. So you can deploy several of those next to each other. And basically, so that way, you have one kernel, which is container ready, and then you can have several containers running in parallel, which can have their own set of libraries and their apps, and they can run next to each other with very little overhead. So, yeah. So basically, well, as I said, it's a hermetically sealed application. Yeah, you have runnable artifacts, it's introspectable, and, well, Docker is really the way how people have been doing containers. Now, how do we do things? How do we run containers in Google? We didn't only come 2014, 2013, so there was no Docker, unfortunately. So it's a little bit different, but many of the ideas are the same as we're doing, as now the open source community is doing. So we've been running containers for a long time. Since I've been there, since 2004, we've run these cluster things. And yeah, and why did we do this? Well, for the same reasons. We wanted to isolate resources. We wanted to make sure that we can run several applications on one machine in parallel. We wanted to have like predictable service on how many resources we need if in management, but also overcommitting. So basically, we can use more resources on the machine than we have, but without overcommitting too much. It's a bit like the airline overselling seats. You should hardly ever notice it, but they do it all the time. And so basically everything we do runs in a container. So we have container management on every bare metal machine. They all look the same. Hardly anybody cares about the machine at Google at all, because everything runs in a container. It's over 2 billion containers a week we start at Google. Yeah, I guess we end slightly less than that, but not really, because we always start them all the time. And we had a journey. We started 2004 with our own container technology. Now you have to see, 2004 we didn't really have any customers running VMs, etc. So we were always lucky thinking about our infrastructure because we were our only customer. So we had limited isolation between the resources. All of that was bad because different teams had to work together, but it was not as bad if you worked together between completely different issues as well. But we worked together to have some kind of resource isolation container, so you can say I want to have 2 CPUs and that amount of RAM for that container, and whatever that one gets slice of 1 CPU, etc. And so we helped, and we released C groups into the Linux kernel in 2006. In 2013, we released Let Me Containerify That For You, which is a framework similar to Docker, where you can like build containers, schedule containers, etc. Didn't quite get that much traction. In 2014 is where we really went public with a lot of open source stuff in containers, and we released Kubernetes, we released C-Advisor, which is part of monitoring for containers, etc., and Google Container Engine, which is not open source, but which is our own product on top of Google Cloud Platform. So one thing I have to say, what we always do in Google is we run declarative services. So we want to say, well, here you have a service, I built something called Gmail, I need 500 terabyte of RAM or something, and please run that, and I'm done. So the software engineer doesn't think about where something runs. It just, you want to know, you just give some inputs on, okay, you run 100 copies, not more than 2 can be down, etc. But you don't say what is on which machine, or please run this now on that machine, or that machine was a bit fuzzy yesterday, so don't use that, etc. Has a lot of advantages because you save yourself a lot of thinking. The one disadvantage is probably it's a bit harder to track changes. You have to look, has the change been done, where has something been deployed, etc. So that's maybe the only disadvantage. Now, how do we do this in Google? Well, we built a system which contains of our own managed base OS. We have a container manager on every machine, which we also have a system container. The system container has things like health checks and general health checks over the machine, and looks into monitoring and has a monitoring agent, logging agent, and all of that. And then we have different containers for different services running on the machine. And and then on top of that, on some other machine in the cluster, we have a scheduler which just schedules which containers run on which machine, etc. And we built the system and have been improving it since 2004. Last year we published a paper called Omega, which kind of shows where we are going with this, how we are doing the scheduling exactly internally. So this is what we've been doing for years, and it's not so different from what we think everyone should be doing because it works quite well. Now, however, one thing to do a bit different than open source Docker is packaging. So we statically link binaries, dependencies, and we assign them, and so we end up with signed static binaries which push into the container. And while Docker does something different, it has a completely change-rooted environment in the container, so you have a full stack. You can basically deploy any kind of application. You don't need to link stuff together. And you can use even your package managers to build things and change things in the containers, like you can use apt-get, etc. And so the file structure is less guaranteed, but it's much easier to get started, and we actually think the way Docker is doing this is much better. And well, maybe we should have done that. We're not going to change now because we have so many containers running, but we think for external folks, this is really the way to go. So for our open source offerings, we chose to run with Docker instead of trying to open source our own way of packaging containers. Now what do we offer in container products? It's kind of different things. Well, first of all, why should you care? Well, because of all the things I mentioned. You want to deploy things reliably, you want to make sure you can schedule, you want to have portability, like you have with Docker images, and you can manage things much easier because you have a loosely coupled service. And this leads all to better efficiency, better performance, because, well, if you run microservices in VM, you lose a lot of performance. If you run them in one big VM in separate containers, you will get much better performance because you can overcommit, because you're not limited to a very small slice of networking on every single service, etc. I/O is much better, so this is much easier. It's also much easier once you use containers to integrate it in your continuous integration system. It makes it much easier and reliable. And also, because when you use a cluster system with scheduling, etc., you have a robust system. Monitoring is already included. It's kind of self-healing, and it's what I'm going to demo a little bit later. Now, how does the service we offer look like? It's kind of the same thing. We have a managed-based OS and a container manager. Well, so basically the VM image is just container optimized, and it has a container manager pre-installed, which is and it has health checking and restarting also on that. And based on that, a cluster scheduler can schedule containers. So when you run this container optimized image on Google, you only care about the container environment and your applications, and pre-installed is the operating system, logging, initd, sshd, Docker. So this stuff, you just don't really think about it because it's kind of managed by us. And, well, then you need a scheduler which schedules containers across machines and replicates them, resizes the cluster, etc. And Docker doesn't do that. So there was kind of a gap, and nobody else really was doing that either. But it's really important if you want to run scalable services. Otherwise, everyone runs their own scripts, and this works well for a while, where you only have, like, I don't know, 3 or 4 or 5 or 6 or 10 servers of something. You can still build your own monitoring. You can still script it that when one dies, it brings another one up or something. But it's not really scalable if everyone does it yourself. So we released Kubernetes in the open source community a few months away, which is, Kubernetes is like the Greek helmsman of a ship, Greek word. So it's kind of the scheduler which brings all this cluster together. And we released it in a very early stage into open source. So it's posted on GitHub, kubernetes.io if you go on the web page. And so we released it and immediately said, listen, this is the first step, but with the vision what we think a cluster scheduler should have, based on what we do internally, and based on what we learned from that, and what we maybe even can do better. And immediately lots of people came online to the idea of having a cluster scheduler. Obviously our examples were all on how you run Kubernetes either on your own machine, on your own laptop or server or whatever, or how you run it on Google Compute Engine. But we really want to make sure it runs on any system. It runs, the idea is later it should also run hybrid cloud, multi-cloud, so whatever system you should use, it should make this portability go further because you suddenly can schedule resources across different ways. Lots of partners came online within a few weeks. We were a bit surprised even. So there's IBM, there's Microsoft, which integrated in Azure. Red Hat is doing their own kind of system. Will use Kubernetes for their own clustering system they're building. Then we have VMware as a partner, so you can run Kubernetes container. You can schedule Kubernetes and run it on VMware. Well, Docker is obviously a partner. CoreOS as a container optimized Linux is a partner, and Mesosphere kind of makes sure that Mesos and Kubernetes, they can run in parallel and play nice with each other, so they don't bite. So what is Kubernetes? Well, it basically is what I already said. It's a container scheduler, but it's a bit more than that. It's not just, okay, I look for a free machine and I deploy something. Because there's a few more ideas. There can be loose coupling, but there can also be tight coupling of containers. And the tight coupling we call pods. So there could be a web server which should always be close to the content management system. They should always live together. So when you schedule things, you don't schedule containers, you schedule pods. And this makes the idea more possible that you still run microservices, because you still want to be able to pull out the container management system and update it, but you always want to have it physically close to the web server. So you always deploy pods together, but the containers are basically run and updated by themselves. So, so this is one concept Kubernetes has. And you basically template them together in one way, and you say, okay, I make a pod out of these things and can have several containers. Then we have a concept called labels. And labels for everything which doesn't need to be on the same machine or something, but you want to group containers or pods in different ways. So for example, you can have a label called front end, or well, for this web server you can have front end, you can call it it's front end, but everything else which is part of the front end you also give this label, or you can give it a label which is called production, one staging, one experimental, etc. These are like the typical labels you would give for things, and it just makes it easier to query and dashboard and whatever. So it's a semantic identifier you have. And then we have replication controllers, and that makes the whole idea of scheduling and self-healing possible. So you can say, okay, I want to have this web server or front-end pod, I want to run 2 of these, and it schedules 2 of these. And when one of them dies, for whatever reason, it brings up a new one. And that way you can forget about the system. You just say, I want a replication controller, I want X replicas of that. But now you have several replicas of that. How do you address this? And this is what a service is. And a service is basically giving a special port on any of the workers to a service. So all these front ends are now bundled in the front end server. So it's basically a load balancer, which you can address any of them, and it will make sure that the service gets put on any which can answer the query. Now, Kubernetes is in a quite early stage, so some things are not up to the stage yet where we think like the load balancer is done in software now, it should integrate with an external load balancer, it should have a much more logic on getting data from the pods, on how much load they have, etc. Some of this is not implemented. And if you look on Kubernetes on GitHub, you can actually see the public roadmap, and you can see what do we need for a 1.0 version of Kubernetes. I think a few days ago we released 0.52. Yeah, so we are about halfway there. And there's a list of features and which basically need to be done. But given that this was only published at I/O the first time, it's come far, and yeah, the idea was to get there before the end of the year. Well, end of the year is near. I don't know if they will make it quite to 1.0 or 1.0 release candidate, but let's hope so. Let's hope. There's a lot of developers in Google, but not only Google. Actually, I heard Red Hat has several heads running full-time on Kubernetes, and some of the other bigger partners probably have major contributors as well. So if you look at the project, you see it's not only 1 or 2 guys working on it, it's a real project. Now, you all of that comes together, and basically what you can do with that is you can run resilient services. Like you can roll out new version while the old version is still there. Then you can scale them down, slowly bring them offline. You might always know, well, when you roll out services rapidly, you know that people tend to be very sticky, stickier than you think. Sessions tend to last long, so you might have to keep the old version online for like just a little bit longer, scale it slowly down, and then bring the new one up. At some point you need to make the cut. And that way you can do things like rolling updates, etc. And I will demo that. Now, the question is, do you have to build all of that yourself, like bringing up the cluster and installing Kubernetes on it? And well, obviously the short answer is no. And just a few days ago, I think it was the 3rd of November, we released Google Container Engine in public alpha, which means anyone can try it who has a Google Computer Engine account, anyone who has a Google Cloud Platform account can try Container Engine, and I will demo it. And it's designed for a multi-cloud world. It's integrated in Google, but you should be able to take anything and bring it up somewhere else. So basically what Container Engine does, it creates and manages nodes and a master. Well, nodes in Kubernetes are called minions, and these are basically Compute Engine VMs in this case, and then there's one master which runs the whole scheduler, and Kubernetes as open source software is pre-installed in the newest version, so it's a completely managed service for you. So it's very easy to get started, provision clusters, well, they say in seconds. To try it out, you have a fine-grained control of the cluster. You say exactly how much you want to run and what you want to run, and it runs Kubernetes on it. We don't have an SLA on it yet because it's still alpha. We don't have pricing on it yet, so at the moment you just pay the VMs you need to run the containers. We don't charge anything extra for Container Engine, and we have a lot of ideas though. So I'm going to try to jump into a demo. Let me start with my Google Developers Console. Read that? Yes. And you can see, just because it takes a minute, I already created my cluster, but I just show you how in Container Engine, which is under compute in Container Engine, that's open for everyone now, and you once need to enable the APIs and you can get started. Basically, you can either use our command line tool or you can use our GUI to create a new cluster. The Wi-Fi works, yeah. Let me create a cluster called DevFest. You tell it, description, what you want to run. You say where you want to run this cluster. I choose the zone in Europe, and how many VMs you want to have. I'll start relatively small. I say I want 5 machines with 4 CPUs each. Let's say high memory. So it will create 6 VMs in total because it also creates the master node. And I click that and it starts creating the cluster. So that's all it takes. I will nevertheless, for the rest of the demo, work with the cluster I already created because this takes around 1 to 2 minutes. And if I think I closed my SSH, so that's bad. Okay. No worries. And as you can see now, you can see all these nodes being created in the Compute Engine. But actually, because I'm working on a Chromebook, I do all the SSH from another Compute Engine machine myself. Oh, actually, hold on. I think I still have it. No. Sorry. I do have a slightly better terminal here, though. Okay. So next thing I want to do is on the cluster I already have called Kubernetes. I want to deploy a simple service, and let's start with a service which is already there, which is, let's say I want to install WordPress, and I can go to the Docker registry and I can find whatever service I want. Hopefully someone built it. So for WordPress, username Tutum built a WordPress service which you can run on Docker, and you can therefore also run it on Container Engine. So what I will do is I use the tool gcloud, which is the new cloud SDK. Since Container Engine is public preview, I use preview, and the thing is called container. There should be bash completion, yeah. And I say, well, first I want to see pods. I want to create a pod. Oh, and I want to create it in the cluster. I actually set it as a default, but just so you see how you put this in normally, in my cluster, I want to create the pod called WordPress. And I use the image called tutum WordPress.
You forgot create though.
Oh, I forgot to create. Very good. Container pods create. I think this should work. And then I need to set a port. I want to run it on port 80. That seems like a good idea. Oh, I took it. So now I can just do the whole thing, show a list of all the pods. So it's hopefully should have deployed by now. Yeah, and it deployed that on my node 2, which has this IP. And I can now go on this, and hopefully on port 80 I get nothing. No, I get WordPress. So I can go on, install my WordPress, and well, that's how quickly you can get started. Now actually let me delete that one, because otherwise it will not make me happy. Delete WordPress. Well, some other demos have visualizations that show all pods, and I don't want my WordPress there. just to make that sure. So that's how you deploy a ready-made application. So that's quite simple. Now what if you build your own application? I have a little guestbook application which is running and which uses Redis on the back end, as everyone knows. Such a magic guestbook here, which is running on my local machine, well, on my GCE machine, which is not part of the cluster. And as everyone knows, some guestbook where you can write massive parallel to it, messages like hello DevFest, or if you would go to this IP, you could write something as well. Obviously, I need a massive scale backend and needs to run in memory. That's why I use Redis. So now let's try to bring this to Container Engine, and I wrote a little bash script which is called turnup guestbook, which does basically the thing. It creates the Redis master service, it creates several Redis slaves, and it creates the front end, which is this guestbook application, and it deploys it on the Kubernetes cluster. And now I can do the same thing before I did and list my containers, and once I resize my, you can see it gets a bit complex, and but yeah, so that's why we have a visualization layer which I built on my local machine, which shows me, there it is, what has been deployed now. So I have 3 frontends deployed which talk to 2 Redis slaves, and the 2 Redis slaves can communicate with the Redis master where I have only one. Now, because hopefully the guestbook is running, let's say, on this machine, should also work. Because I need now to get this massive spike of users. Oh, this does not. I deployed it on another pod, I believe. Yeah, okay. Now, because I expect a massive spike of users from here writing messages, I might need more than 2 of these. I might need more than 2 of these Redis slaves to run all the load, and I want to resize my cluster. Let me run this, actually. And I do Kubernetes config resize the Redis slave controller. I want to have 4 of those instances. Now, if I reload my graphical visualization of my Kubernetes cluster, it already resized the whole cluster to 4. And hopefully all of you can write your great messages there now. Now with it's just as easy to bring that down again. So good luck. You're done, unfortunately. So that's how quickly the service goes again. Now, last but not least, I want to show you a little bit how the cluster self-heals, because sometimes things happen which we might not expect. Because it looks quite bad with this Redis, I made a bit of a simpler demo for that. And let me first start again, web proxy, which visualizes that for me. So what I do, I wrote a very simple service which runs a web server and shows an image which then can be shown running on several instances. So again, I will, oops. And so what I first do is I bring up this replication controller with two web servers, very similar to what I did just now with the guestbook example. And I see I have two web servers running which show a picture of some kind of underwater-like snail thing. And now I want to scale this up because I expect a lot of load, and I have a script for that which runs the same kubeconfig scale, and it brings up two new ones, and within a few seconds, and that's how you see how quickly you can scale with containers. You have 4 nodes running showing this. Now, another thing I talked about is you can do rolling updates. And that's a lot what we do in Google. That's what I think all the major service providers do. When you roll out a new service, you roll it out node by node, very slowly, over a bunch of hours, to make sure that nothing bad happens while you do this. I sped it up for this demo bit, so I will do every 10 seconds, I will update one of the nodes, and will bring up a new image, where I build a much more advanced image web server provider, and the first node I killed, bringing up the new node, starts serving the much more beautiful image of a kitten, and now every 10 seconds it does the same thing again, and it restarts one of the nodes with the new version of the web server providing a new image. Okay, so still deploying. So once that's done for all the 4 nodes, I will be the bad guy and actually try to kill one of the kittens and see what happens then. So, okay, this should be through now. So what I do is start with a very simple way of doing that. I log in, and I can do that with the same G-Cloud tool, but now using Compute Engine, not Container Engine, to log into one of the Kubernetes minions running one of the web servers, so run one of the containers. So I log into the node 1. -1. Maybe I should say what I want to do with this node. I want to SSH into it. And on that node, I can now do sudo docker ps to see all the Docker containers running. And I can see I have 3, 2 pauses, 2 pauses, which I don't need, 1 web server with the kitten, and 1 cAdvisor. So I want to kill the container with the kitten, so I do sudo docker kill case 13 e, that should be enough. And now if you see, it's gone, but yeah, it's gone, but it didn't really take long, and new container is brought up to start that. Now I can be even worse and maybe just kill 2 of these nodes directly on Compute Engine, shut them down. And hopefully the same thing should happen. I actually never tried this out. Because I didn't want to bring up the cluster from the beginning. There we are. Yeah, there's 2 which are down now. And maybe the issue is now that it can't bring up more machines. Terminated. Oh, there's bringing 2 new ones up, but doesn't quite know yet where. Maybe now I'm out of resources, so yeah, that shows how Kubernetes is still, well, because I only have 2 nodes now, I want to run 4 of them. I don't want to run 2 on the same node because I only have to pod 80 open ones, so that's where it fails, because my cluster is not big enough. With, hopefully with Kubernetes 1.0 and beyond, you can then push stuff even between clusters. So to stop this whole thing, I want to tear down my whole, I'm still on the Kubernetes node. I want to tear down the whole cluster and stop the service. All right. Okay. So that was it for the little demo on how you can scale, how you can self-heal, how you can sometimes not self-heal because you don't have the capacity, and where this might be going. That's basically all from me. If you haven't tried Google Cloud Platform, you can use the code Try Kubernetes on cloud.google.com starter pack to get a $500 voucher. And for the rest, I think I have like 5 minutes for questions. All right, any questions? Yes?
Are all the scripts that you used as the examples, are they all online?
Most of them, so if you go on GitHub, on GitHub, Google Cloud Platform, Kubernetes, that's actually on top. Then if you go on example, the update demo is the kitten demo. The guest book, it's not exactly the same way I used it, but it has some, like it's using the same Redis guest book, so those are online, yes. And so you can play around with it. If you look on the getting started, it has quite a few ways of running your own Kubernetes cluster now on most of the major clouds, I would say. Yeah, so it's quite easy to get started. Yeah?
How do you deal with things that can be killed and restarted on the fly, like file servers or database servers?
In Google, we try not to have them. Yes, we only we run the Google file system, which can be restarted. But yes, if you or now Colossus, I guess if you have a service which relies on data, which cannot be simply restarted, maybe a traditional VM is better. Maybe you could see if Mesosphere can do it. And maybe you can see if you can somehow replicate the underlying file system with something which is container ready, so decouple it from the actual application to make it sure that it can be modular and like any single system can be restarted. Well, obviously it's not like I could kill the whole Google file system and bring it back up. It relies that always a minimum number of nodes is up. So it doesn't solve all problems, but the day-to-day problems, let's say. Any other questions? Yeah.
How do you, or is it possible to control the routing? For example, you have a new version of the app and you want only special requests to be routed to the new version.
So this is not possible with Kubernetes today. I think it will depend a lot on how load balancers will be integrated, and because it's a bit hard to define a standard there. Generally, load balancers can do that, so it should be possible. And it doesn't make sense to use a software load balancer or non-optimized load balancer for this kind of service. Like how it is now, the load balancer runs on every worker node, and it probably doesn't make much sense to do it that way. It does make sense to use a load balancer service, which is part of a cloud or part of or integrate with maybe even physical load balancer servers, etc. And then I can see this happening. It's possible now in App Engine, which can you also use containers in what we call managed VMs. But yeah, otherwise it's coming soon. Okay. Any more questions? Yeah.
You mentioned you use a container in App Engine. So when is the case we should use managed VM, and when is the case you want to do Kubernetes there?
Yeah, so it's a bit funny because we use containers in like many layers. As I said, everything in Google runs in a container, so even Compute Engine runs inside containers, but it's never the containers you see. The App Engine, you know, also runs in containers, but in these Google containers I talked about, so you never see them. With managed VMs, you can run them in a VM as opposed to a container which we control. So that helps you getting rid of some of the limitations we had to put, because we had to put security boundaries, and now the VM will put the security boundaries. Now with managed VMs, with the newest version, which we just launched in open preview, you can run a Docker container inside the managed VM, which will actually allow you to run any kind of language. If you want to run App Engine with Node.js or Scala or whatever, you can deploy a server inside that Docker container which responds to requests, and this can run inside a VM. So it mostly depends on what kind of flexibility you need. If you're okay with App Engine as it is, you should probably use it. You can think of using managed VMs because some of the VMs are more powerful. You can go to 16 cores, so alone for that. Sometimes you should use managed VMs because you need libraries which are not supported otherwise. And sometimes you should use managed VMs because you want to use languages which are not supported, but you like some other ideas of App Engine, like the auto scaling and the A/B testing, etc. Okay. More questions?
No, anyways.
Good.
Thank you.
Perfect.